Pre-calc students, here are some examples from your homework assignment tonight. We're going to start with number 3. Two opposing players in capture the flag are 100 feet apart. On a signal, they run to capture a flag that is on the ground midway between them. The faster runner, however, gets off to a slower start by a tenth of a second. And we've got the equations modeled for us. So x1 equals 10 times t minus 0.1, and x sub 2 equals 100 minus 9t. All right, so what's happening here is we have two people running toward each other. All right, the question we want to make sure we understand is, well, which one of these two is the faster runner? And this doesn't exactly give us the speeds, but you can figure out what's happening with the speeds here. This first runner, x1, is the faster runner. And that, of course, leaves x2 to be the slower runner. I can tell that because the delay of a tenth of a second was the faster runner. All right, so it says that we need to write a parametric equation to represent the flag in this scenario. Now, we know that the flag is in the midway between them, so we know the x value is, of course, 50. Now, the height of the flag isn't really so important, but if we want to be able to actually see it on our graph, I would do something like this. I would say the flag is 5 minus 2x. Something like that should do the trick. All right, let's go ahead and punch these in to our calculators. Now you can see I've punched in the 3 parametric equations. Before I go look at the graph, I need to consider the window. Now, I'm doing a little bit of estimation, but how long will it take these players to run and capture the flag? And remember, they're actually only running 50 feet. I think t minimum of 0 is great, and I could do something like maybe 5 seconds for the max. And that means I'm going to change that step. We'll start with 0.1, and then we'll adjust. Okay. Now for the x minimum, remember we're starting, we're 100 feet apart. So really we need to go 0 to 100, although I want to stretch that just a little so we can see just beyond where those runners happen to be. The height is really not very important. I just want to be, I don't need a whole lot of other stuff, so I'm just going to go like 0 to 5. And 0 to 5 represents the height, where what I decided the flag would be. And it's kind of interesting that I chose 5. I don't even know why I chose 5 for the height of the flag. It'll work, but anyway, 5 minus 2x, I really didn't need to do that. I could have easily just done something. As a matter of fact, I'm going to change that now, because the more I think about that, the less that I like it. I'm just going to make that a basic 2x instead of 5 minus 2x. There's really no reason for that kind of silliness on this lesson. All right, so 2x. All right, I'm going to go back and change that y3 as well. Let's take a look at the graph. Okay, you can see the two runners running toward each other. Over here on the left is the faster runner. On the right is the slower. Now, in retrospect, I perhaps should have set my time to be a little bit more than 5 seconds so we could see when both runners would actually get to that flag. So I'm going to change it to 7, and now we have overlap. All right, so here we go. The t values we chose were 0 to 7. The t step was 0.1. You can see the x and y values. We chose our own that were a little bit different than that, but they were close enough. We'll call it good. All right, the follow-up questions here. Who captures the flag and at what time? Well, what I'm going to do is trace the faster runner first and see how long it takes the faster runner to get to the 50-foot mark. And I'm looking at x values here, and this is a nice round. Every tenth of a second he travels another foot. So I can see right there the fast runner takes 5.1 seconds. And if I were to switch and trace the slower runner, I can see that he's still not quite to the pole. So I know the faster runner is there. And it says by at what time? Well, the time then is 5.1 seconds. And then by how many feet did he capture the flag? Well, that's answered by switching to runner 2. And I can see that runner 2, they're at 54.1. So they're still 4.1 feet away from the flag.